Hi everyone, in this we will learn how to implement a population count, also known as Hamming weight, using a combinational adder tree. A population count circuit determines the number of logic 1 present in binary input vector. For this example, let the input vector be x6 down to 0, which consists of 7 input bits, that is from x6 to x0. Our objective here is to count how many bits are equal to 1 and produce the corresponding binary count at the output. Now here in the first stage, the input bits are grouped into pair and added together. We generate 4 intermediate sum, which is S0 is equal to x0 plus x1, S1 equal to x2 plus x3, S2 which is equal to x4 plus x5, and finally S3 which is x6. Now since adding two 1-bit number can produce value from 0 to 2, the output S0, S1 and S2 require 2 bits. The signal S3 contains only x6 and therefore remains a 1-bit value. And at the end of the step 1, we have reduced 7 input bit into 4 partial count. Now in the step 2, we combine the partial count generated in step 1 and generate S4 equal to S0 plus S1 and S5 equal to S2 plus S3. The maximum value for S0 plus S1 is 2-bit and 2-bit, which is 4-bit, and which requires 3-bit to represent. Similarly, for S5, here S2 is of 2-bit and S3 is of 1-bit, and also this will also fit in 3-bit. So both S4 and S5 can be represented using 3-bit. And at this stage, the 4 partial count have been reduced into 2 large count. And finally, we add the 2 intermediate result, which is S4 and S5. This produces the total number of 1 present in the input vector, and this final result is the population count or Hamming weight of the input vector. Now let's understand how the adder tree works, which is shown in this diagram. This arrangement of adder is also known as combinational adder tree, and it is widely used in high performance digital system where fast bit counting is required. At the top here, we have 7 input bit vector consisting from x0 to x6. And now here in the first stage, the input bits are grouped and processed by 2 full adders. The first full adder adds x1, x2 and x3 and producing sum and carry output. Similarly, the second full adder adds x4, x5 and x6 and also generates a sum and carry. At this point, the 7 input bit have been reduced into a smaller set of intermediate sum and carry signal. In the second stage here, the first full adder adds x0 along with the sum output from the 2 full adder in the first stage. And at the same time, the second full adder combines the carry output generated in the previous stage. This stage further compresses the intermediate result. Now the final output here, we can see that, which is represented by a 3-bit binary number. And this 3-bit output represents the total number of logic 1 present in the 7 input bit, which represents the population count or Hamming weight. Now here if we observe, we can see that here by performing multiple addition in parallel and reducing the result level by level, the adder tree achieves a much faster count compared to a sequential approach. This is why this is an efficient technique for population count. Thank you for watching. See you in next video.